In this video, we're going to learn the basic trig ratios. So you probably heard of trigonometry before. So really what that means, if you think about the breakdown of trigonometry, so trigon is the Greek word for triangle, and metric is Greek for measurement. So together we're talking about triangle measurement. And specifically what we're going to talk about in this lesson is the trigonomic ratios. So there's three important trigonomic ratios which you have to know for geometry, and they only work for right triangles. So that's going to be important here, that when we talk about these ratios, there's special measurements of right triangles. So we need to have right triangles if we're going to be using them. And one thing also to keep in mind is when we talk about a right triangle, the longest side or across from the right angle is the hypotenuse versus the other two sides are called the legs. And another thing, though, when we start talking about these right triangles is with the relationship with respect to an angle. So I'm going to go ahead and just sketch a right triangle below. So let me get my right triangle here. And in this right triangle, we know that across from the right angle is the hypotenuse, and these other two sides are called legs. But more specifically, we're going to be talking about these two sides and what they're called with respect to their angle. So a symbol that's used quite often here is this symbol right here, and this is called theta. And this is just basically a variable, just like x or y, but it's commonly used for angle measures, especially when you're dealing with trig. So when I talk about these other sides, I'm going to talk about them with respect to this theta. So I'm just choosing this to be the acute angle I'm talking about. I could also be choosing this one if I want. I'm just purposely picking this angle down here. So what that means is this leg over here is opposite that theta. So if I start at theta, go opposite it, this side or this leg is actually called the opposite. So it's opposite to that angle. And then the side that's next to that angle is called the adjacent. So what that means is the hypotenuse will stay the same. That's always going to be the longest side, always across from that right angle. But then the opposite and the adjacent are going to change depending on which theta, where we have theta, which acute angle we're looking at. So notice I keep saying which acute angle we're looking at. So that means when we talk about sine, cosine, or tangent, and we're talking about them with this theta, we will never be using the 90-degree angle. So that's an important thing here. So we have three basic trigonomic ratios, and we are only ever going to be using the non-90-degree angles, so meaning the acute angles. So theta will either be down here or it'll be up top here. And then the opposite and the adjacent will change depending on where theta is located. Hypotenuse will always stay across from the right angle. So if you look at what these ratios are, you've probably seen the sine, cosine, tan buttons before in calculators, but what they actually mean is they're ratios. So instead of me saying this whole thing here, length of the leg opposite the angle to the length of the hypotenuse, I could just say sine theta. And that means the same thing as saying the opposite side to the hypotenuse. What's the ratio between those two sides? So it's just a shortcut. It's just a word. Instead of describing or stating this whole ratio every time, we can just say sine theta. So that means you would look at theta, you would talk about the opposite to the hypotenuse. That's what you would give. So the shortcut here, instead of writing all this out, you can just say sine theta is equal to the opposite over the hypotenuse. Cosine, instead of saying the adjacent to the hypotenuse, you can just say cosine of the angle, or cosine theta is equal to the adjacent to the hypotenuse. And then tan is equal to the opposite to the adjacent. So that's just kind of the shortcut. So these are the same formulas. It's just the shorter versions of the ones that are typed already in your notes. Another thing here is an acronym to help you remember these. So there's lots of different ways. The one that I use is I just say SOHCAHTOA. So what that means is sine is opposite over hypotenuse, cosine is adjacent to the hypotenuse, tan is the opposite to the adjacent, because it can get really confusing as to which sides go with which trig function, or which trig ratio. So this is just a way to kind of help you remember these three formulas. So let's actually look at how do you use these formulas. So down here, we have this example 1 where you see a triangle labeled ABC and you see sides across from those labeled with lowercase letters. So that's just something right here to point out that when we're talking about a triangle, if we're saying that C is the angle, well then the side across from that we're going to call lowercase c, because if you remember angles, you always use capital letters for the points. And for sides, normally you name them using 2 capital letters, but if you just want to use, make it easier on yourself, you can use this lowercase letter. And by using the lowercase letter as the angle across from it, it makes it a little bit easier to carefully place everything. So that's typically how we're going to do things, just so that it makes it so we're consistent. So if I look at this first example, it says write expressions for sine, cosine, and tangent of angle A. So I'm going to use my acronym, SOHCAHTOA, and I want to come up with the 3 ratios for angle A. So I'm going to start with angle A. I'm going to go across from that. That side's going to be the opposite. I'm going to go next to it. That's going to be the adjacent. And the hypotenuse is always the side across from the right angle. Now you might be thinking, well, isn't the hypotenuse technically adjacent to angle A? It is, because it's next to it. But when we say adjacent, we're talking about the side that's not the hypotenuse. We're talking about the leg. So it has to be one of the legs. So the opposite and the adjacent are always legs. Hypotenuse is always its own thing. It's always the longest side. So if I want to write out my 3 ratios, notice how I write this. It's going to be sine of the angle, because you have to talk about the angle, because remember, if I change this to angle B, well, now everything's going to be different. So sine of angle A, so the ratio with respect to angle A of the opposite to the hypotenuse. That's what sine stands for. So the opposite is A, to the hypotenuse is C. So the answer to sine A is A over C. And A over C, remember, stand for sides because I'm using lowercase letters. So it's important to distinguish between capital and lowercase. If we look at the next one, cosine of A, well, cosine of A means using angle A, tell me the ratio of the adjacent to the hypotenuse. So the A to the H. So it's going to be B to C. And then tangent of A is the opposite to the adjacent, the TOA, so O over A. So using angle A, opposite is A, to the adjacent is B. So that's using angle A. Now, the second part of this says go ahead and do the same thing, but do it using angle B. So now if I'm looking at angle B, watch what happens. This is now the opposite. And this side is now adjacent. So that means if I go to write these ratios, things are going to change, because now if I'm looking at sine B, which again is why you got to have that angle there, because if I just write sine both times, I'm not using the same sides. So sine of B means going to angle B. What's the opposite? It's B to the hypotenuse, which is C. So again, you have to specify your angle. People will forget that angle, but the angle is so important because it's the ratio with respect to that angle. So then we look at cosine B. Cosine B, start at B. Adjacent side is now A to the hypotenuse, so A over C. And then tangent. So tangent is TOA, so opposite over adjacent, so B over A. And there you have it. There's your different ratios. Now you can kind of see some patterns here between these, and that those patterns are going to exist all the time. You start to see some similarities between the sine and cosine, And then you should see that you see some reciprocals here for the tan. And we'll talk about more about that, but just kind of pointing out some patterns. You should see those. And then example 2 wants us to find the 3 ratios with theta, of theta. So that means I'm looking at this. I'm only looking at this angle here, and I want my ratios. So in order to come up with our ratios, remember we have SO, CA, TOA. We want all 3 ratios. The first thing I'm missing here is I don't have the hypotenuse in any of these. Or on this triangle, I don't have the hypotenuse, and I need that in order to be able to write sine and cosine. So that means I need to find the missing side of this right triangle before I do anything. So what I'm going to do, it's a missing side of a right triangle, we can use Pythagorean theorem. So since this is the hypotenuse, let's go ahead and do Pythagorean theorem first. So my first step here is going to be a squared plus b squared equals c squared. So we have 5 squared plus 2 root 3 squared equals c squared. So we have 25, and remember to square both of those. So that ends up being 4 times 3, so it ends up being 12. So add these up. So we get 37 equals c squared. So square root both sides. So c equals the square root of 37. So square root of 37, we're just going to leave as is. And if we just put that up top here, square root of 37, now we can go ahead and do our step 2, which is to come up with our ratios. So I can write sine of theta now. Remember, you have to specify that angle is the opposite. So opposite theta is 5 over the hypotenuse, which is square root of 37. Next one is cosine. So cosine theta is ca, so adjacent. So this is my adjacent. It's the side next to theta. So adjacent over hypotenuse is square root 37. And then the last one's tan. So tan theta is opposite over adjacent. So 5 over 2 root 3. So there you have it. So there are your different ratios. Now we can do what we call rationalize these, where we multiply everything by the square root on the bottom. But for right now, I just want to focus on let's just get our ratios. And we can talk a little bit more about that in class. So here's your 3 ratios, your acronym to remember them. Go ahead and check your understanding problems, and we will talk more about these in class tomorrow.